Hello, welcome to In 5 Minutes. Next is again a bias series clipper. As you know, diode and resistance, load resistance are in series. The current flowing is the same and the voltage source again, that is biasing is adding a DC voltage source in series with the diode, hence bias series clipper. Now how to go about the analysis of the bias series clipper is positive and negative half cycle. Now first look at the position of the diode and the supply voltage. Can see the positive of the supply voltage is connected to the negative terminal of the diode, hence the supply voltage 2 volt is reverse biasing the diode. So in this case, how the circuit will look like? The circuit will look like negative positive negative positive. The diode is open circuited, then you have RL and across which we are measuring the output voltage VO. Here you have plus minus VI. This is 2 volts and the diode. Since this 2 volt is reverse biasing the diode, what will be the current flowing through RL? The current flowing through RL open circuit hai, matlab the current flowing over here is 0. Current flowing over here is 0 ampere, hence the current through RL is 0, hence the output voltage is 0. Till which point? Until and unless 2 is overcoming the supply voltage. Now what will happen in positive half cycle? Positive half cycle mein this is negative positive negative positive negative positive diode. Just for illustration I am drawing the diagram again. You have plus minus VO. What you are doing, this supply is reverse biasing the diode. Again positive minus you have VI. Again what you can see, this positive terminal will more reverse bias this diode. Again the supply voltage is reverse biasing and the positive half cycle is also reverse biasing, hence the diode will remain open circuit for entire positive half cycle because of effect of 2 volt and the positive cycle, both are reverse biasing the diode. So in the entire positive half cycle you will get 0 voltage. When you apply KVL over here, what will be the equation? Since the current is not flowing, we cannot apply KVL over here, so your VO equals to 0 for entire positive half cycle. Now coming to the negative half cycle, when you look at this equation, negative half cycle mein you will have the supply voltage DC supply which is reverse biasing the diode plus minus VI, you have RL and the output voltage plus minus VO. This is 2 volts minus plus then VI. The value will take obviously as negative. I am considering for simplicity positive negative. Now when you apply KVL, it will be VI KVL to input till output, or you can say KVL from input to output. It is VI plus 2 minus VO equals to 0. Now this 2 volt is reverse biasing the diode, hence when you simplify this equation you will get VO is VI plus 2. So when your VI is 0, you can say this point we have done with the positive half cycle, again we have reached 0 point. So ideally you should get output as 2 volts, but since the circuit for 0 input voltage will be, the diode will be open circuited and no current will flow through RL, and hence you will not get any output voltage until and unless you are overcoming this 2 volt in the negative half cycle. In the negative half cycle your VI is varying from 0 to minus 4 volts, right? So until and unless you are overcoming 2 volts. So when your input is minus 1, minus 1 plus 2 will give you 1 volt. Again the diode is reverse bias because you have not overcome this 2 volts, you will not get output. Output will be 0 volt in this case. This is just for calculation, but ideally you will not get any output, that is output is 0 volt. So when you are overcoming 2 volts, for 2 volt it will be 0. For input say minus 2 volts, your output will be 0 volts. After that when your VI increases, for minus 3 you will get VO as minus 1 as shown over here, and for VO for minus 4 you will get it as minus 2. So you will get output only after you are overcoming this 2 volt in the negative half cycle. Positive half cycle you won't get any output, so you will get output only after minus 2. So you will get only output for minus 3 and minus 4. So you can see the waveform how you need to draw. In the positive half cycle you are not getting any output. This is the positive half cycle, you are not getting any output in positive half cycle. Negative half cycle also, after you are overcoming 2 volts, suppose say this is minus 1, minus 1, minus 2, minus 3, minus 4. So after minus 2 you are getting the output. Minus 3, when you draw it on both the sides you will get this point over here. This is the x-axis and this is the point. So you get output only in this part, and it is going from -3, maximum value is -4 volts. That means your zero level, which was initially at this point, is now shifted to here, which is 2 volts, because of the series 2 volt in the supply in the circuit.